Day 146, Physics Circuits Homework, Problem 2D. This one's a little bit harder than the previous one. Where you start at this one is with the 6 and the 3. They are in parallel. So we have to combine those first. And you would just do 1 over our total equals 1 over 6 plus 1 over 3. The total combined resistance of the 6 and the 3 will be 2 ohms. Then you would draw that diagram, replacing the 6 and the 3 with a 2. The 1 ohm resistor is still present, 6-volt battery. 2 ohm, replacing the 6 and the 3, 1 ohm, and those are simple series resistors, so they combine to give you 3 ohms. So the final circuit, simplified, is simply a 6-volt battery with a 3 ohm replacement resistor, and then you go to your Ohm's law. V equals IR for the circuit. 6 volts equals I times 3. And when you divide that, you get 2 amps. So the current is 2 amps. That's indicated by that blue arrow I just drew. Same thing here. Each of those 2 resistors, if they both existed, would be receiving 2 amps. There's 2 amps in each of those. That's 2 amps, 2A. So let me fix that a little bit. That's 2 amps of current. 2 amps of current. Okay, they each have the same current, different voltages. We can calculate their voltages by Ohm's law. So for the 2 ohm resistor, V2 would be the current through that resistor times its resistance. So the 2 ohm resistor has a current of 2 amps, a resistance of 2 ohms, so its voltage is 4 volts. And then for the 1 ohm resistor, V1 equals its current times its resistance. So V1 would be the current, still 2 amps, same as the 2 ohm resistor, but it's got a 1 ohm resistance, so its voltage is 2 volts. Notice once again the 2 volts here plus the 4 volts here is the 6 volts total. So the voltages add up. They have the same current. They do not have the same voltage. But going back up to the very top diagram, once again, there is, in this wire here, indicated with the blue arrow, there is 2 amps of flow, 2 amps of current everywhere in that, along that blue line, 2 amps. That current gets to this spot right there, and it splits. Twice as much goes to the bottom as to the top because it's an easier pathway, but how much goes down towards the bottom? And how much goes up towards the top? Because that 2 amps splits, doesn't split equally. Well, the top resistor up there and the bottom resistor in parallel, they have the same voltage, different currents. But what is their voltage? And here's kind of the key. It is given down here by the 4 volts, because this 4 volts applies to the 2 ohm resistor, this resistor right here, which is the replacement resistor for the 3 and the 6. That might be the toughest move in this particular problem. So that 4 volts applies to this resistor right here, and therefore it applies to each of these 2 resistors. They all have the same voltage. So I'll put that up here in the diagram. This is 4 volts. 4 volts, not 6 volts. So now I can use Ohm's law for the 6 ohm resistor. So we have V6 way over here on the right equals I times R for the 6 ohm resistor. We don't know the voltage yet. Well, yeah, we do know the voltage. We know the voltage is 4. We don't know the current. I times 6. So the current in there is 4/6, which is rounded off to 2 sig figs to decimal form, 0.67 amps. That's the current through that 6 ohm resistor. That will go in the table in the spot. This spot right here is where that number will go. The 3 ohm resistor, let's use red. Okay, so V6 equals I times R. I'm sorry, back that up. We're talking about the 3 ohm resistor right now. The voltage for the 3 ohm resistor equals its current times its resistance, and we know it's 4 volts, that was highlighted in green on my diagram, equals I, which we don't know, but a resistance of 3, you could surmise it's going to be twice as much as the current through the 6 ohm resistor. And indeed, it's 1.33. It's 1.33 amps, which is twice as much as 0.67 amps. But together, those two numbers that I have right here add up to 2 amps. That's how the current splits. That's how the 2 amps of current splits. So the 2 amps comes around up here at the diagram. So you start here, 2 amps comes around, the battery pushes 2 amps. That 2 amps gets right here and splits. Half of it goes, not half, a third of it goes this way. It's 0.67 amps, and 2/3 goes this way, twice as much, the 1.33 amps we just calculated. So that 1.33 amps goes in this spot for the 3 ohm resistor. The 1 ohm resistor has 2 amps, and you can figure out the voltages that I have written down, and then calculate the powers by multiplying current times power, remembering that power is in watts.